Stanford University.
All right, well then, welcome to Lecture 5 of CS 193P. This is spring of 2016. And today we are going to first work a little bit more on FaceIt. I'm going to show you a little kind of some cool features in the interface builder part of Xcode. That's the part where we're building our storyboard. Then we're going to start talking about what FaceIt's view controller's model really should be. Okay, because right now, if you look at the code in our controller of our MVC for FaceIt, it's blank. There's nothing in there. So we need to do some work there. I'm going to come back to the slides, and I'm going to talk about gestures, okay, which is the input side of UIView. And I'll do a demo where we put some gestures in FaceIt. And then, time permitting, I'm going to end with some more slides, starting to talk about multiple MVCs, which is the gateway to building bigger applications. Okay, so that's what's on tap for today. So let's dive right into the demo here. I'm going to do these two things I talked about, which is interface builder and a model for our FaceViewController, which is going to be a facial expression, not surprisingly. All right, so here we are in FaceView. This is where we left off last time. I'm going to quickly enhance our FaceView to be a little cooler right now. If you remember from last time, our FaceView has a mouth, which we can configure a little bit. We can make it smile and frown. And then it has two eyes, okay? And I'm going to add two things. One, I'm going to make it so we can close those eyes. And another thing I'm going to do is I'm going to add eyebrows, okay? Now I'm going to do this really fast because the code that it takes me to do this, you really wouldn't learn that much from going through it, but it's pretty much more the same as the stuff we've been doing. So I'm going to add a couple of more public vars because these are going to be configurable things. One is whether the eyes are open, which is going to be a bool, and I'm going to say that they're going to start out open, okay? So it's just going to be the default. And then I'm also going to have something called eyebrow tilt, okay, which is going to be a double. And I'm going to start at 0.0. And it's similar to the kind of the mouth curvature. So we're going to have -1 be full furrow, and 1 will be fully relaxed eyebrows. Okay, so similar kind of thing as we had for the mouth curvature. So let's do the eyes open first. Quite simple. In path for eye right now, you can see that we use a path for circle, so that's why our eyes are circular. So if my eyes are open, I'm just going to continue to do that. Okay, we'll use the path for circle. But if the eyes are closed, then instead what I'm going to do is do this, which is basically use a line. So I'm just going to draw a horizontal line if the eyes are closed. Okay, very simple here. Bezier path, move to a point, draw a line. Okay. And then for the brows, you see, we have path for eye and we have path for mouth. So I'm just going to make a path for brows, which I think I have here, yes. So here's our path for brow. And it's pretty straightforward. It's just drawing a line, but this line is tilted depending on how much tilt we want. And of course, we need a little function or a little static here to go up in our ratios, which is the relative position of the brow to the skull radius, just like we have all these other things that are relative to the radius, okay? And now that we have path for brow, just like we did with path for eye and path for mouth, we'll go ahead and stroke those. So I'll say path for brow, the left one, stroke, and then we'll do a path for brow, the right one, and stroke. Okay? So let's go ahead and run, see what we look at. We should have eyebrows now. Okay, yeah, look, we got eyebrows. They're kind of cute. And we should also be able to close the eyes. So I'm going to change this eyes open to false. See if that works. It does. Eyes closed. We could set our eyebrow tilt maybe to, I don't know, -0.5. See what that does. Okay, we got some tilt there. Okay, so you can see with eyebrows we can make more facial expressions. That's why I put them in there, so we'd have a little more room to maneuver when it comes to facial expressions. I'm going to do a couple other things here. One is there's some constants I have in here, like my face is always blue. I don't really want that, so I'm going to make that be a var. So I'm going to call it color. So I'm going to go up here and make a var color, which is going to be a UI color, and I'm going to let it be blue by default. Oops. UI color, blue color by default. And then I'm also going to do a var for the line width. Okay. Currently our line width is always 5.0, but I'm going to, and we'll make a default be 5.0, but I'm going to change all those 5.0s with this var. So let's do that. There's 1, 2, 3, 4. Okay, that's our 4 things: eyebrows, eyes, and mouth, and the skull. Okay, so now we've kind of made our face view quite externally usable. Okay, all these public functions are something that a controller is likely to use because we're part of the view. Okay, we're a generic face drawing view, and so we can be used by any controller that might want to draw a face, okay, which is the kind of controller we happen to have now. It's drawing a face. But if you look at our controller right here, it's drawing a face, but doesn't really control that face much, okay? It has a view that it has in its storyboard where we put our face right here, but it's not really doing much. And we'll fix that in a minute. Now, one thing that's kind of annoying is if we look in our storyboard right here, okay, here's our storyboard, we don't see that face. And, okay, well, we only have one MVC here. We know it's a face. The fact that it doesn't show up there, But what if we had like 20 view controllers? And this was just this was the face, but there's a whole bunch of other ones. It'd be really cool if that face would show up here. Okay, so we could see it in Interface Builder. And in fact, that's really easy to do. All you do is you go to your view, okay, your custom UI view, face view, and you just put @IB designable at the front. And if you say @IB designable, then Interface Builder is automatically going to assume, oh, you want me to draw this thing. So you can see it's even compiling it and drawing it. And so now it appears here in my storyboard. Okay, so that's pretty cool. But one thing that's not so cool is if I click on my face view and bring up the inspector, I can only inspect attributes about my face view that it inherits from view, like its background color and things like that, right? It'd be really cool if I could inspect things like eyebrow tilt and mouth curvature and the color and the scale. Wouldn't it be cool if I could do all that in Interface Builder so I could set up the face how I want it to initially look, maybe, Interface Builder, and you can do that too. If you go back to Face View, all of these things right here that are settable, you can just put in front of them @IB inspectable, okay, which means they'll show up in the inspector. And so I'm going to make all of these things be inspectable. Put inspectable on all these guys. Okay, going to Interface Builder. But if I go here and bring up my utilities, now you can see I've still got all the view stuff, but now I've got all these face view things. So I can set my scale to 0.5, okay, and that makes it small. Or I could set my color to orange. Okay, San Francisco Giants color, all right. I can make my line width be 2 instead of 5, or it's a little thinner. Okay, I can set my mouth curvature in here. Let's say minus 0.5. Right, eyes open, on. There we go. Okay, see that? 0.9 again. All right, so that's kind of cool that we can do that. And in fact, when we first run our application, it will use these values. So let's go ahead and run. And you're going to see it's going to keep this exact face, line, the color, the line thickness, all these things. Just like if we had set any other attribute over here, background color or something like that, when we run, of course, those would be the things it starts out with. Okay? Now, one little thing to watch out for when you're doing this is these IB inspectable vars, you have to explicitly type them. See, most of these I wouldn't even need to type, right? Swift could infer that that's a double from there. But if you're using the IB inspectable, you have to explicitly type. Basically, Interface Builder can't infer it. Swift can, but Interface Builder can't. So you need to make those explicit. Okay, just a minor deal there. Okay. Now, one other thing I want to talk about here with a view is if somebody sets the scale to something, okay, in the code, like let's say our controller over here, let's say we had some code in here to set the face view scale, it would actually do nothing. Okay, nothing would change on screen. And why is that? Well, because when you set this scale to be 0.5, all you did was set this var. You didn't do anything else. Okay, so that var is set to 0.5. And if the face were to redraw, it would redraw smaller, but nothing is causing the face to redraw. So anytime you have these public vars that you allow to be set, you need to make it so that when they change, the view redraws. Okay, now how are we going to do that? Well, we're going to do that using these property observers we talked about before. Remember the did set and the will set? These are little pieces of code that get executed whenever this, in this case, gets set. Okay? So if this got set to something, then in did set, I want to redraw. And how do I redraw? Maybe I say self.drawRect. Do I do that? No. I would fail this class if I did that, because we never call drawRect. We say instead set needs display. Okay? Set needs display is how we tell the system, please, I need to be redrawn. Okay? And it'll happen at some time in the future, very near future, but sometime in the future. Now, this is so common to do this. Usually, we will take out a little bit of these carriage returns here and put this all on the same line. Okay, like that. And we're going to put this after all of our little vars here. So we'll put it in place of the comment there, put one there. The same thing here, just so you can easily see it, because we're a little bit screen real estate challenged here. All right, so now all of these vars, if someone sets it, it's going to cause this thing to redraw. What's really cool is if they set 3 or 4 of them right in a row, it's not going to redraw 3 or 4 times. It's going to keep saying, I need to be displayed, I need to be displayed, I need to be displayed. But it's not going to actually display until a little bit later, and they'll all get displayed at once. So it's much more better performance to delay slightly to do these things. That's not even the primary reason this does it this way, but it's one of the reasons. Okay? Everybody got that? Okay, so we're almost always going to use this did set. Now you're going to see we're going to use the did set in the controller as well for a slightly different reason. Okay? But the did set is super convenient. All right? Okay, so let's talk about our controller here. It needs a model. Okay? I have created a little class over here called facial expression, which I'm going to drag in. I'm going to copy it in here. Okay? When you drag things in, you almost always want this selected. So pay attention to that. You want it to copy in. You don't really want it having a link to the other thing most of the time. So I'm going to copy this little facial expression in. Let's take a look at facial expression. You'll see, we'll see facial expression right here is our model. See, it's not a UI thing. It imports only foundation. It's completely UI independent. Its idea of a face is not really the same as a face view. Okay, a face view thinks of mouth curvature and eyebrow tilt and things like that. This doesn't have any of that. It does have eyebrows, but it just has relaxed, normal, furrowed. That's the only thing it knows about, those 3 states. Same thing with mouth. It's frown, smirk, neutral, grin, smile. That's it. It doesn't have mouth curvature. It doesn't even know what that is. Okay? One thing kind of cool here, you see these are enums. Notice I have functions on my enums here. Okay? I'm not going to talk about the implementation of those. If you read the reading assignment, you should be able to figure these out. But I got some functions in here of my enums. But really, facial expression is just the eyes, eyebrows, and mouth. Okay, which is specified by these enums. And some of the enums, like eyes, even has a state. FaceView can't even represent that face. It doesn't have a squinting. It only knows how to have eyes open and close. So the point here is that this model has to be interpreted by the controller for that view. Okay, the controller is going to have to figure out, okay, what does relaxed eyebrow mean? Well, for the face view, it means some sort of eyebrow tilt. And so the controller has to figure out what that is and tell the view. You see? So this shows the primary role of a controller in your MVC is to interpret the model for the view. It also interprets input in the view for the model, and we'll see that when we talk about gestures. Okay? That's its kind of primary purpose in the controller. So let's make our controller do that. Let's make it turn a facial expression into something in the face view. Okay, so in our controller, the first thing we're going to do is we're going to create a var here, which is a pointer to our model. And it's just going to be a facial expression. Okay, and we're even going to set it to some facial expression to start off here. Remember, with a facial expression, which is a struct, by the way, we get the free constructor. By the way, I can infer this. I don't need to have that, right? So I get the free constructor, which is what? Eyes are, we'll have them be open, and then eyebrows, we'll have them be normal, I think is what it is, normal. And then we'll have mouth, which will have be a smile, let's say, okay? So this is going to be our default value of our facial expression. So this is the model for our MVC. Now, what's interesting about this model is what if it changes? Okay, if it changes, I need to update my view, right? If it changes from a smile to a frown, I need to change my curvature of my face view. So I'm going to use that same magic, the did set thing that we did before, to update my UI whenever this facial expression changes. And since this is a value type facial expression, if any of the vars in that value type change, this did set is going to get called. Okay, if this were a class, it wouldn't. So luckily it's value type, so this is going to get called. So we need this update UI. This can be any function we call. I like calling it function update UI, but you can do whatever you want. And it's going to be private. It's a func, update UI. And inside here, we have to update our face view. Okay, well, if we're going to update our face view, we need a pointer to that as well. Okay, how do we make a pointer to something in our view? Yeah, we control dragged, right? We made an outlet. So let's just do that. Let's bring our storyboard up here. We've got our face view. Here's our controller right here. I'm just going to control drag from the face view into here. And I'm going to create an outlet. I'm going to call it face view. It's my face view. Okay, we used display in our calculator. This is our face view. I click OK here. And now we've got this outlet. Okay, so now we've got a pointer to this face. So now we can talk to this face, set its curvatures and all that business. Right? So now that we've got a pointer to this, in our update UI, we can just talk to it and set it based on what the expression is. So how are we going to do that? All right, well, first of all, let's start with the eyes. So if the facial expression's eyes are in the state open, then we're going to send a message to our face view saying eyes open equals true. So that's an easy one. Okay, our face view is very similar to our model in that way. And same thing here, closed, we'll do FaceView.eyesOpen equals false. But what about case squinting? Okay, we don't really have FaceView.squint. Okay, we can't do that. So I'm just going to say eyes open equals false. If you're squinting, eyes are closer to closed than they are to open. Okay, so it's the best I can do. And this is the way sometimes a controller is. Its view might not be perfect at representing the model. It's doing the best it can. Now, we might be sending in a request to the FaceView guys on our team saying, hey, we want a feature where our FaceView will do squinting because we got squinting in our model. And they might be, okay, we'll take it under advisement. We'll see. But for now, we're kind of stuck. So we're going to do squinting is the same as eyes closed. How about our other two things? Okay, we got these curvatures to deal with, right? So we want to say something like FaceView.mouth curvature equals something based on the expression's mouth. But the expression's mouth is like grin and frown. What the heck are we going to do? How are we going to convert that to a curvature? And what I'm going to do is I'm actually going to create a little private dictionary. I'm going to call it mouth curvatures. Okay, plural. And I'm going to make it equal to a dictionary. Remember, we can make a dictionary on the fly with square brackets. And I'm going to have the keys of this dictionary be mouth curvatures for my model, and I'm going to have the values be mouth curvatures for my view. Okay, doubles. All right, so for example, let's do facial expression.mouth.frown. Okay, that's a key, and the value is going to be minus 1.0. That's a curvature that goes along with that. See what I'm saying? So I'm just creating this dictionary that's basically creating a mapping between my model and my view. So how about grin? Notice, by the way, when I do grin, okay, it's already inferred the fact that we're doing a facial expression mouth, so I don't need to repeat this every single time. I can just say the grin. And the grin we'll say is 0.5. So it's not full smile, just kind of a little bit of a smile. But a full smile would be 1.0. And a smirk, that sounds kind of like a little bit of a frown, but not too much of one, so we'll do minus 0.5 there. And then there's this neutral mouth position, which will have be 0.0. Okay? So I've created these mouth curvatures in the table, so now down here I can just let my mouth curvature equal mouth curvatures sub expression.mouth. Okay? Now, the problem with this, and you can see there's an error here, and can anyone see what the problem here is? This is a dictionary lookup. What is a dictionary lookup? What type does it return? Optional, yeah. So this is a double, it's not an optional, okay? So how are we going to deal with this? What if facial expression gets enhanced some future date and the expression's not in here? I'm going to have it default to 0. Okay, remember this defaulting thing right here where you can take something that's a double, and if it turns into nil, if it returns nil, then you can have a default value there. Make sense? Bar there. Okay? Everyone's cool with what I did there? Right. Hopefully from calculator it's very similar to that, looking things up in a dictionary. So I'm going to do the same thing with the eyebrow tilts. Okay, the eyebrow tilt equals eyebrow tilts, which is going to be a dictionary, and I'm going to put the facial expression dot eyebrows in there, and I'll also default that one to 0 if we can't find it. And then I'll just make a private var here. We'll call it eyebrow tilts, and this one we'll do facial expression dot eyebrow dot what do we got here? Relaxed. So we'll have relaxed be a CG float, which is 0.5. Okay, so that's kind of relaxed eyebrows. Notice oops, not CG float, that's 0.5. Okay, that's a double. Okay, the eyebrow tilts are doubles, so I did not want CG float there. Okay, how about dot furrowed is minus 0.5 tilt, and dot normal will make be 0. Okay? Got that? All make sense? So we're doing the same lookup there. Okay, so now we've matched up our model with our view. We've kind of interpreted our model for our view. Now, let's go ahead and run this and see what this looks like. Okay, now, this doesn't quite look right, because if we look at our model, it's supposed to be eyes open. Okay, that's good. Eyebrows normal? No, those are not normal eyebrows. Those are kind of furrowed. And then mouth is supposed to be smile. No, it's a frown. In fact, all of this here, instead of the UI looking like the model, it still looks like we set it in the storyboard. Okay? So why is it that our update UI is not getting called here when we initialize our facial expression? That's because if you're setting a value during initialization, did set is not called. Okay? It's only called if you set it later. Now, why is that? Because you know that when things are being initialized in Swift, they have to be fully initialized before you can do anything with them. So of course they have to be fully initialized before you can do any of this stuff either. Okay? So this initialization did happen, but this update UI didn't get called because this was happening during the initialization phase of our FaceViewController. Now, if we were to set the expression later, this would get called, our UI would change. So how do we deal with that? Okay? What we're going to do there is something we should have done anyway, which is when our FaceView outlet is set by the system, we're going to do did set here and update our UI. Okay? So this did set is called when iOS comes along shortly after your MVC is created, and it wires up this outlet. Okay? It hooks up the outlet so it's actually pointing to that FaceView. So as soon as that happens, now we have a hold of our FaceView. Now we can update it. Okay? So we're updating it both when our model changes and the first time our view is hooked up. Okay? And this is something also that we would usually put on the end like this. Okay? We might even do it here. I'm going to leave this here just to emphasize that we're doing this, but again, this would be a common thing to throw on the end there, okay? All right, so now let's run. Now when Swift iOS basically comes along and hooks up that FaceView, boom, it's going to be updated with our model. Okay? And so now if we change our model here, let's make the eyebrows be relaxed. We'll make the mouth be a smirk. Let's get those eyes closed. Okay? And we change all this in the model, then our view should be reflecting our model. Okay, and there it is. Okay? Sound good? Everyone understand what we're doing there with our model? Okay. So let's go back to the slides and talk a little bit about gestures, and then we'll come back and add some gestures to our FaceIt right here. Okay, so we saw last time how to draw in a view. We drew the mouth, we drew the eyes, we did the eyebrows, all these things. We know how to do that pretty much, right? We're using the UI Bezier path in our draw rect, not so hard. What about gestures? Okay, so this is input from the user on the screen. Now, we can get the location and movement of every single finger that touches down on the screen. That's possible, okay? There is API for doing that, but we virtually never do that, ever, okay? Why don't we do that? The reason for that is that the user thinks of interacting with your UI as a gesture, like they're swiping or they're pinching, okay, or they're panning around. Those are gestures that they are making. So iOS has an abstraction layer that lets your app think of the input as gestures as well. Okay? So you're going to get those gestures and do something when they happen. There's predefined gestures. The great thing about that is a swipe is exactly the same thing in every single app. Okay? It's like, you know, the speed of swiping and how far you have to swipe, all that's exactly the same in every single app because every single app is using these gestures. Okay, if you had to do your own swipe, well, you know, did the person swipe fast enough or was that a pan? You'd have to do all that logic yourself. It would be a pain in the neck and it would be inconsistent between applications. Okay, so gestures are recognized by instances of a class called UI Gesture Recognizer. Okay, good name. But UI Gesture Recognizer itself is abstract. You never actually instantiate one. Instead, there's a bunch of subclasses of UI Gesture Recognizer, and those are what you instantiate to get the kind of gesture you want. So there's pan gesture recognizer and pinch gesture recognizer and tap and swipe gesture recognizer, etc. Okay? Now, when you want to use a recognizer, there's really two parts to it. Okay? One is you have to get some UI view to take on this gesture recognizer and recognize that gesture. So there's the gesture recognition part, which is done by creating a gesture recognizer and then asking a view to use it. Only views can recognize gestures, not controllers. They can't recognize it. Only views. Okay? So part one is to create the gesture recognizer you want, configure it how you want, and then ask some view, please start recognizing this. Okay? Then part two is, what if the recognizer does recognize it? Then it needs to have that handled somehow. And that's done with a gesture handler. So you got gesture recognizers and gesture handlers, okay? And the handler is called as the recognizer goes through basically a state machine of recognizing this gesture. Okay, and we'll talk about what that state machine looks like. But it's called repeatedly. The handler is going to be called repeatedly as the gesture goes through the process of being recognized and moving and all the things it does. Okay? Now, usually the first of these things, the creating of a recognizer and adding it to some view, it's usually done by your controller. Okay? It doesn't have to be done by your controller, but it's a good way for your controller to essentially turn on that gesture in one of its views. Okay? The views are the minion of the controller anyway, so the controller wants to control its minions, so it might usually be the one that wants to add the gesture recognizer to a view. But some views, the gesture recognition is so fundamental to who they are that they add it themselves. They add it to themselves. For example, scroll view. Okay, what would a scroll view be without a pan gesture to scroll up and down? It would be useless. It wouldn't even be a scroll view anymore. So scroll view adds a pan gesture recognizer and a pinch gesture recognizer to itself, probably in its initializer. Okay, but a lot of the times it's your controller that's adding the gesture. Again, the controller can't do the recognition of the gesture. Only a view with the gesture recognizer can, but the controller can add that gesture recognizer, create and add the gesture recognizer to one of its views in its view. Okay? The second thing, that handler that handles it, well, that could be handled by the controller, or it might be handled by the view. Could even be handled by someone else. Would never be handled by your model because UI independent. But it could be anyone in the controller or view camps can handle it. Generally, kind of, if the thing that's the gesture is doing is only modifying how the view displays itself, like in our face view, if it was just the scale of the view or maybe somehow it was changing the color of the view, then the view is probably going to handle the gesture. Okay, it's going to both recognize it with its recognizers and handle it. But if the gesture is changing the model, then definitely the controller would be the handler. Do you see why that is? Because the view can't see the model, okay? But the controller can. So the controller would set itself as the recognizer of anything that's going to affect the model. And we'll see that in the demo as well. Okay, so how do we add a gesture to a UI view? We've decided we want a view, in this case, let's say, to recognize pan. Okay, a pan is putting your finger down on the screen and moving it around without lifting it up. And when you lift it up, the pan is over. Okay, that's what a pan is, basically panning your finger around on the screen. All right, so what if we wanted to do that? Well, so we have to somewhere in our controller code add a pan gesture recognizer to the view that we want the panning to happen in. Okay, well, a great place to do that is in that did set, okay, of the outlet. Because as soon as that view that we want to pan, as soon as we get a pointer to it, let's immediately just add the gesture recognizer right there. Okay? And we know that this did set right here, okay, we already saw this in the demo I just did. This did set, when you're doing it to an outlet, this gets called only once. It gets called when iOS first hooks up that view. Okay? Perfect time to go add a gesture recognizer. Okay? So we're going to do that. First, we are going to create the pan gesture recognizer. Okay, here's a concrete subclass of UI gesture recognizer called pan gesture recognizer. It takes two arguments here. The first is who is going to handle this gesture when I recognize it. Okay, so this pan gesture recognizer is saying, hey, if I recognize a pan, who's going to handle it for me? And the answer is self. So that's the controller, okay, because it's an outlet in the controller. So the target self means the controller is going to handle this pan itself, okay? The second argument here is what method do you want me to invoke in self when this gets recognized, okay? Now there's some kind of funky syntax here. This has to be an Objective-C runtime compatible selector. Okay, that just means a selector, a method, okay, the name of a method that is visible to the Objective-C runtime. Now, for this to be visible to the Objective-C runtime, this method must be in a class that inherits from NSObject. Remember I was talking about that NSObject thing, and sometimes you're going to need it. Well, here you would need it. Now, you don't usually care about that here because this is almost always being handled by either a UIView which definitely inherits from NSObject, or a UIView, which definitely inherits from NSObject, right? So you usually don't care. Okay, you're not usually going to be trying to send this to some object that's a Swift object that doesn't inherit from NSObject. But this syntax here means create an Objective-C compatible selector. Okay, selector just means kind of an identifier for a method. And here is just the class, a dot, and then the name of the method, including the argument names. Don't forget the argument names here. Now, this pan method that I'm going to show you on the next screen, it has one argument. That argument is the pan gesture recognizer. So just like when we have target action and we have a button that has the sender is sending itself, same thing here. When we have a pan gesture recognizer and it starts to recognize, it sends this pan method here to the view controller with itself as the argument. Now you might say, why is this underbar right here? Why don't I have the name of whatever this first keyword is? And that's because I don't really care what that name is. I just want to make it clear I want the version of pan that has one argument. Now, if I had multiple pan methods that had different first names there, then I would have to put the name in there. But I can put underbar here because underbar in Swift means I don't care, whatever. Okay? I don't really care what this is. It's a substitute for I don't care. So I don't really care here. So I just want to introduce that you can do this underbar here. But if I don't put this colon underbar here, then it's going to try and call a pan method that has no arguments. So be careful. If you want the one that has the gesture recognizer as an argument, you got to put that in there. Okay? So that's specifying the selector. And then I just turn on this recognizer by taking the view, this is the UI view, this panable view, okay, and adding this thing I created as a gesture recognizer. Okay, as soon as I add that, this view is going to start recognizing pan gestures. Okay, and when it does, it's going to send this method to self, which is the controller. Got it? Okay, make sense? That's what we're doing there. All right, so now let's talk about how we implement this handler, this method right here, this pan thing. Okay, what does that look like to implement? To understand how we're going to implement such a method, we needed to understand a little bit more about the concrete subclasses of UI gesture recognizer. So let's look at pan. Okay, so pan, UI pan gesture recognizer, it has a few methods on it that are specific to panning. Okay, for example, it has translation in view. It takes a UI view and tells you how far the pan has moved in that view's coordinate system. Okay, which is exactly what you want for a pan, because you want to know where you are, so you always want to know how far you've moved. It even has velocity in view, where it'll tell you how fast the pan is happening. Okay, if you're ripping it around versus going really slow, like if you had a drawing app, when you're going really slow, you might be drawing really carefully, and if you're zipping it around, yeah, you're making big arcs or something, who knows. And it even has set translation, which is setting this. Why would you ever want to set this? Well, if you don't set this, okay, then this translation view is going to be the cumulative translation in view. Okay, it's how far the pan has moved since it started, the cumulative thing. What you want instead is how much it's changed since last time you told me about it. Okay, you can constantly reset this to 0. If you constantly reset this translation to 0, then the next time you get it, it's going to be the translation incremental. Okay, the tiny bit it moved since the last time. Okay, so you'll see in the demo that we will reset this to 0 every time, because we just want the incremental panning. Okay. All right. So the abstract superclass of UI pan gesture also provides a very important var, which is the state. Okay, I told you that these gesture recognizers go through a state machine. Okay, and this is how you can find out in your handler what state the gesture is in. So they all start around in this state possible. Okay, UI gesture recognizer state.possible. Then for a discrete gesture like a swipe, once the swipe happens, it immediately goes to the state recognized. Okay, it recognizes the swipe. So your handler gets called, the state will be recognized. For a continuous gesture like a pan or a pinch, okay, it goes to the state began as soon as the pan gets held down. And as soon as the pan starts moving, it keeps going to the state change. Change. The handler keeps getting called over and over with changed. Okay? And every time this translation is changing. Okay? And then when the finger goes up, then it goes to ended. Make sense? Now there's a couple other states here, failed and canceled. Like if you're doing the middle of a pan and a phone call comes in, okay, then your gesture is going to get canceled. Okay, so you might or might not have to deal with that. If you're dealing with your pan incrementally, then who cares if it gets interrupted? You were moving the thing incrementally. If you're dealing with your pan with some big thing at the end, when the pan ends, then you better do in here what you were going to do when it ended. Okay, but a lot of times you don't care because you're doing all the work in change, so canceled and failed is just like ended, but you don't notice the finger going up. Well, no big deal. Okay, so now that I have all this information about a pan gesture, how do I make a handler that handles a pan gesture? Okay, this is what the code would look like. This code is going to be in my controller because I said the controller is going to handle the pan. And first I'm going to look at the state, okay, here's that pan underbar colon. You see, this pan takes an argument. Okay, instead of underbar there, I could have put gesture because that's what I called it here, gesture, but I don't care. But this one takes an argument. You could have pan with no arguments here and nothing there, and this would not pass the pan gesture along as an argument. But here I need the pan gesture because I need to know how far the pan has gone. Okay, so next I'm going to switch on the state that the pan gesture is in, and if it's changed or ended, then I'm going to update something in my controller. Okay, otherwise I'm going to ignore it. Okay, if it's canceled or failed or if it began, I don't care. I'm only interested when it moves. Okay, so that's why I'm only looking at this. Now, I want to show you this kind of cool thing in Switch. Hopefully you got this in your homework. But there's this thing, fall through. Remember that Swift cases don't fall through to the next case like they do in C. Okay, but you can force them to fall through with fall through. Now, I probably wouldn't write code like this. I would just say case.changed, comma, .ended. Okay, that's an easier way to do this, but I just wanted to show you fall through. Okay, all right. So here inside, when things have changed or ended, I'm going to get the translation in the panable view. Okay, remember this is that outlet. I'm going to get that translation from the gesture. And then I'm going to go and update something that depends on where the pan is. I know where the pan, how far it has moved. So I'm just going to update something that needs that. And then I'm going to set the translation back to 0. Okay, this also could be CG point dot 0 if you want. But see, I'm going to set it back to 0 so that the next time I get called to my handler, next time it comes back around, this translation will be the incremental translation from the last time it sent it to me. Everybody get that piece? Okay. All right. So that's it. That's what the handler looks like. Pretty straightforward. Okay. We'll see this in the demo. It's not too bad. Okay. Let's briefly talk about some of the other concrete gestures besides pan. There's pinches. Pinches is 2 fingers down, pinching in and out like this. Okay? And here, what you're getting instead of the translation is the scale. So if I start my fingers here and I bring them out twice as wide, that would be a scale of 2. If I start them here and move them in halfway, that's a scale of 0.5. Okay? So I'm scaling whatever on my screen. And again, I can get velocity, how fast I'm pinching. Rotation is 2 fingers turning them. Okay? Like you're turning a knob, and it'll tell you how many radians you've turned. Okay? And again, velocity, how fast you're turning. Swipe gesture. Okay? The swipe gesture you usually have to configure before you use it. You have to say, do you want a left-going swipe or right-going swipe or up or down? Okay? And also 2 fingers swipe or 1 finger or 3 fingers. Okay? You have to configure that. Then you add the gesture recognizer, and it'll only recognize it if all those things are true. 2 fingers swipe up. It has to be a 2-finger swipe up. Otherwise, it doesn't recognize it. Okay? So that's swipe. Tap, which seems like it would be discrete, is not quite a discrete gesture. But you also configure it with how many taps. Is it a single tap or a double tap? And 2 fingers or 1. Okay, you configure that. Add it. And here, you're going to look for .ended to find out when the tap has happened. Okay? That's because a tap actually has intermediate things going on, like a double tap has the first tap and then the second tap, and it might go through a state change that will call your handler, but it's not done yet. Okay? And you can't look at recognized with tap because it's not a discrete gesture because it goes through those intermediate phases. So you will look for .ended for a tap. Okay? All right, so let's do a demo. Let's see all this in action with our FaceIt. And what we're going to do, first I'm going to add a pinch gesture that makes our face get bigger and smaller. Okay, we're just going to pinch in and out and adjust our scale. And then I'm going to add a pan gesture, actually probably do a swipe. Let's do a swipe gesture that modifies our model. Okay, we're going to use it to make our model happier or sadder. And by making it happier or sadder, then we'll adjust our face view. Okay, let's do that. Go back to our FaceIt here. All right, so how are we going to do this? First thing we need to do is add a gesture recognizer. Okay, and again, I said inside FaceViews did set is a good place to do that. So now I'm going to expand this back out because I'm going to add more code than just that one thing here. Okay, and I'm still going to update UI here, but I'm also going to add a gesture recognizer. I know that this did set is only going to be called once when my outlet is first hooked up to my UI, so that's perfect because I only want to add the gesture recognizer once. And I know that the face view is the guy who has to recognize the gesture. Only views can recognize gestures. So I'm going to add a gesture recognizer. Okay, and you can see that when you add a gesture recognizer to a UI view, it takes a gesture recognizer as an argument. So I'm going to create one here, a UI pinch gesture recognizer. Okay, and that recognizer takes that target and action as the 2 arguments, right? So the target here, in this case, since that pinch is only changing the scale of the view, it's not changing my model, I'm going to let the face view handle this thing itself. Now, for the face view to handle it, it's going to have to make some sort of gesture handler available to my controller. So it's going to have a public method, right, that handles a pinch. So we're going to have to add that to face view, which we'll do next. And the action here is going to be a selector. It's going to be a face view selector. And I'm going to call it change scale, okay? And I am definitely going to need the argument there, so I'm going to do that as well, okay? Maybe this is a little easier to see if I do this. Like that. Okay, so it's giving me an error here because, of course, this method doesn't exist. So it's nice that it actually checks to make sure this exists, okay? So let's go ahead and add this method right here. Okay, this is the method that's going to handle when a pinch happens. Okay, we're going to put that in our face view. So I'm going to go over here to face view. Put it up here towards the top since it's going to be public. Okay, it has to be public because the controller wants the gesture handler to call it. So change scale. It's going to have a recognizer as its argument. Okay, that UI pinch gesture recognizer. Okay, so it's nice that when we're asked to handle the gesture, the recognizer is passed along to us. And this is really easy to implement. I'm just going to switch on the recognizer's state. And if the state is changed or ended, and yes, you can do it that way in switches in Swift. You can have multiple things there. If it's changed or ended, then I'm just going to set my scale to be multiplied by the recognizer's scale. Okay, because here's my scale up here. And so if this pinch goes 2.0, twice as wide, then I want my scale to be twice of what it was. And if it goes down to 0.5, I want my scale to be 0.5 of what it was. Okay? But this is going to be repeatedly called as that thing is moving in and out. So I need to make sure here that I reset the recognizer scale to 1.0 all the time. So that as it moves out, it's going to be giving me the incremental scale in and out. Because I'm actually applying the scale change every single time it moves. Every dot changed here, I'm applying the scale. Okay? Now, of course, we need to have the default state, which is cancel, covers canceled and began and all those things. And in all those states, I'm just going to do nothing because I'm actually tracking the scale and implementing it as it goes along. So I don't even care when it ends. Okay? I mean, it's nice when the fingers go up to do that one last adjustment of the scale, but it's not crucial. Okay? And if we were canceled, we wouldn't get that opportunity anyway. Okay, everyone understand that? This is a public method, yeah?
I guess I'm confused on why you do recognizer.scale equals 1.0.
Well, yeah, see, this is why I asked 3 or 4 times. Everybody getting this? And everyone's kind of like, I think so. Okay. The reason for this is if I don't do this, okay, then as I pinch, I'm going to get the cumulative scale. Okay, so let's say I start here. Okay, and I start moving it out, and it's getting called change, 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 change. Okay, first time is 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 2.0. Okay, so it's getting called 7 times with all those numbers. Imagine if I took my scale and multiplied it times 1.0, and then I multiplied it times 1.2, 1.3, 1.4. My scale is getting gigantic. Okay, that's not what I want. What I want is the incremental scale. So if I keep resetting it to 1, then when it gets a little bigger, I'm going to get 1.01. Okay, reset to 1. 1.01 again. You see? Exactly. I'm not by the cumulative scale. Now, the alternative is I could just have the pinch do nothing until you let go, and then I can set the scale. Okay, but since I'm doing it incrementally, I have to keep resetting it to 1. Okay, good question. All right, so now if we go back to our FaceViewController, you'll see that we don't have an error here anymore on this line because we've actually defined this handler. Okay, so now when we run, and we pinch, we're going to update the scale, hopefully, of our face. So here's our face. He doesn't look very happy, but I'm going to make him smaller so we won't notice. Okay? Now, you might ask, how am I going to pinch with my mouse? Okay, I've got my mouse here. I can't, there's no, how am I going to do it? And the answer is Option. Okay, if you're running the simulator and hold down Option, look, 2 fingers come up there. Okay, now you can mouse down and drag, and it's like you're pinching. You see? Pinching in, pinching out. Okay? Got it? So you can see these gesture handlers are super easy to implement. Okay? We probably had 4 lines of code there, of actual lines of code. All right, now, let's do another gesture recognizer. Okay, let's have this one modify our model. So what I'm going to do here is I'm going to make it so that when I swipe down, he gets sadder. And when I swipe up, he gets happier in a model sense. Okay? Okay, I'm going to make the model happier. I'm not going to move my mouth curvature I'm going to change the model. Now, of course, every time I change the model, that's going to change my mouth curvature, so it's going to work. But we're going to change the model. So to do that, I'm going to do a swipe gesture. Now, a swipe gesture we have to configure, so I have to create a local variable to hold it. Okay, I'm going to call this local variable my happier swipe gesture recognizer. And so I say UI swipe gesture recognizer. Oops, swipe gesture recognizer. And same arguments though, target and action. Okay, so the target here, okay, is not going to be the face view because it modifies the model. It's going to be self. Okay, controller has to be the one handling this one. Okay, and the action, which is the selector, is going to be a FaceViewController selector, not a FaceView one. And we'll call this thing, we'll make this be the happier one, so this is swipe up, so we'll call this increase happiness. Okay, and I don't need the swipe gesture because it's either going to be recognized or not, so I'm not going to have any arguments to that increase happiness method. Okay? Okay, I'll do the same thing here so you can see this a little better. Okay, so this guy right here is not going to have any arguments. So that's going to be a func, okay, increase happiness, no arguments. And when the increase happiness happens, what are we going to do to our model? Okay, well, we're just going to say that our facial expressions mouth equals the expressions mouth dot happier mouth. Okay, so if you look at our facial expression over here, okay, mouth, okay, this enum has two methods, sadder mouth and happier mouth, which will take the current mouth and make it sadder or happier and return a new mouth. Okay, so it's just going to go more happy or less happy along here. Okay, so we got that. Now, so that's going to be fine. This swipe gesture, though, we have to add it to our view. We have to do add gesture recognizer. We haven't done that. And we also have to configure it. So let's configure it. This is happier. So I'm going to have the swipe gesture recognizer's direction, okay, which is the direction of the swipe, equal dot up. Okay, so you're swiping up. That's for happier. And now we'll have it be a single finger swipe, not two. And so now I can just say FaceView add gesture recognizer, the happier swipe gesture recognizer. Okay? Make sense there? All right, let's go try this. Now notice every time we change the expression here, it's going to automatically update our UI because of this did set. You see that? We change this expression, boom, update UI. So let's try it. All right, so hopefully this is still working. Pinching, yes, still working. Now I'm going to swipe up, and sure enough, he's getting happier and happier. Okay? But we better go swipe down also. Okay? We don't have only swipe up. Let's get swipe down in there. And in fact, I'm going to do that by copying and pasting because it's almost the same as this. I'm just going to replace this happier here with sadder. And instead of it being an up swipe, it's going to be a down swipe. And instead of increasing the happiness, it's going to decrease the happiness. So I need a new method here called decrease happiness. And this one's going to get the sadder mouth. Okay, everyone understand? It's real important to understand here that we have recognizers that as they're being handled by the controller, and the controller is modifying the model. And every time the model gets modified, it calls update UI. Update UI is the thing that's going to update, in this case, the mouth curvature. Everyone understand that flow? Okay, so let's make sure that swipe down is working. All right, so swipe down, sad. Swipe up, happy. Okay, sad, happy. Got it? All right, let's do one more gesture. This one, when you tap, he's going to open and close his eyes. Every tap will toggle the opening and closing the eyes. Now, I'm going to do this one a little bit different because we added all these gesture recognizers in code here. You see how this adding gesture recognizers in code? You can actually add these things in your storyboard. Okay, so let's go over to our storyboard right here. Okay, let's get our controller on screen at the same time, automatic. So here's our controller over here. Here's our FaceView over here. If I want to add a gesture to my FaceView right here from my storyboard, I go over here to the bottom, same place I get buttons and things like that. If you scroll way down, you'll see there are gesture recognizers here. You see, rotation, pinch, swipe, pan. Here's tap. I'm going to take tap out and drag it onto the view I want to recognize the tap, which is my FaceView. And when you do that, it actually appears along the top here. See that tap gesture recognizer right there? And you can even inspect it. You could set how many taps, how many touches, okay, how many fingers. Okay, you can also control drag from it over here. Let's do it down a little lower. You can control drag and create the gesture recognizer action, okay, right here. So I'm going to call this toggle eyes, okay? And the argument, I'm going to make it be a tap gesture instead of any object. We all know to get rid of the any object in these little dialogues. Okay, so here's my tap gesture right here. Let's go ahead and go back to full screen. Okay, so here's my tap gesture for toggle eyes. So in here I need to toggle my eyes. So I'm just going to say if the recognizer's state is ended. Okay, so the tap ended. So I'm going to take action here and do the toggle. Then, depending on what the expression's current eyes are, if they're open, then I'm going to make the expression's eyes be closed. And if the eyes are closed, then I'm going to make the expression's eyes open. And if the expression is squinting, then I'm going to do nothing because I don't know how to handle squinting. Okay, make sense? Sorry. Notice I use recognizer.state here. By default, when you control drag, it calls this thing sender. I really like to call this recognizer so that you remember that it's a recognizer that we're dealing with here. Okay, a gesture recognizer. Okay, so let's try that. All right, hit our face. We can make him happier, and we can open and close his eyes. Okay. Maybe later in the quarter when we talk about animation, we'll talk about animating the eyes and we'll turn them so he blinks. Okay? And I'm going to post code after lecture because of the time here I want to make sure we get to the next thing, where I'm going to show you how to do rotation to move those eyebrows. Okay? So rotate the eyebrows down or rotate them up. Okay? I'll show you how to do a rotation gesture. That'll be in the code that I post. Okay, any questions about gestures? Pretty straightforward. Okay? All right, let's get back to our slides.
Is that add gesture recognizer already automatically added to the view, the UIView?
Okay, so the question was, is that gesture recognizer code that I put in there to do the tap, is it already automatically added to the UI view? And the answer, you mean did the add gesture recognizer call get made? Yeah. That basically when I dragged the tap gesture onto the face view, that made it so the add gesture recognizer is going to happen. Make sense? Good question there. Okay, so back to the slides here. Now we're going to start talking about MVCs working together, okay? This is a slide from when I was talking about MVCs, and we talked about we wanted to build big apps, and we're going to do that with multiple MVCs. So we're going to start talking about how we actually do that, all right? The way we combine MVCs, as I talked about before, is that we're going to have an MVC, okay, whose view is made up of other MVCs. Okay? Now, iOS provides for us some MVCs that are like this. Okay? MVCs whose view is other MVCs. Now, it is possible for you to create your own MVCs that have other MVCs as view, but it's really beyond the scope of this class. Okay? So in this class, we're just going to use the ones that are provided by iOS. Okay? These MVCs that use other MVCs as their view. Specifically, we're going to talk about tab bar controller. Everyone know what that is, right? You've seen that in an iOS APS, the little tabs along the bottom, and each time you click on a different tab, what appears on top? a different MVC. Okay? Also, split view controller, mostly you see this on an iPad. You can also see it on an iPhone 6 Plus. This is where you're splitting your screen into two halves. Okay, not really halves, two parts. One side is usually smaller than the other. Okay, so each side, a different MVC. So you see how we've combined two MVCs right there. And then, of course, UI Navigation Controller, the #1 combiner of MVCs. Okay, this is something where you have an MVC, it's got a button in it, you click it, and a new MVC appears where there's a back button at the top, and you can click to go back to the one you were on. Okay, you see navigation controllers in almost every iOS app that's ever been designed ever, except for maybe games that are all one MVC, you're going to see navigation controllers. Okay, so let's talk a little bit about how all these things work. So let's talk about the tab bar controller. This is the simplest of them all, right? You've seen this, right? It's got the tabs along the bottom. Here I've got this one, the dashboard. This is the health app, I think. Got the dashboard selection here. And this entire space is being owned and managed by a dashboard MVC. Not the tab bar controller MVC, but the dashboard MVC. And in fact, this dashboard is controlling not only the contents of here, but it tells the UI tab bar controller what icon to put here and what word to put here. Okay? These tabs over here, these other tabs, their contents are controlled by other MVCs. Okay? So this var tab bar item that you see right there, it's kind of a little bag of goodies that each MVC, remember an MVC is controlled by its controller, so this is a method in UIVieWcontroller, and it has things in there like the icon and the text for the tab, okay, in tab bar item. So you can take a look at tab bar item and you'll immediately see what's going on there. All right, so let's click on a different one like health data, and we get a completely different MVC here. This is the health data MVC, completely unrelated to this one, okay, utterly and completely unrelated to this one, okay. Here, one thing to notice about this is if there are more than 5 tabs down here, this actually still works. It'll automatically replace the 5th one with a tab here that says More. And when you click on More, it'll have a UI tab bar controlled UI in here that has all the other tabs in here. And you can pick them, or you can actually choose to put them down here. Okay, which 4 you want down here. Okay, and that happens automatically for you. You don't have to do anything to make that work. I don't really recommend UIs that have more than 5 tabs down here. It's a little bit of a pain for people to have that more thing, but it's not out of the question. Obviously, the functionality is in there. If you can do it without it, it'd be nice. Okay, here's a couple more tabs. Here's the sources one, another MVC, another. So these are 4 completely separate MVCs. They have nothing to do with each other, okay? The only thing that might link them, maybe they share a model. It's possible, okay? But maybe even not. Okay, so tab bar is what you're going to use when you have MVCs that are completely unrelated. Okay. All right. What about split view controller? So split view controller puts 2 MVCs side by side. So let's imagine your calculator was a graphing calculator. Okay, instead of just a calculator, it could graph what's going on over here. Then on the left here, you'd have your calculator, and on the right, you'd have a totally different MVC, which is a graph view calculator, or calculator graph view, or something like that. Okay. We call this one on the left the master view controller, and we call the one on the right the detail view controller. Okay? When you take your iPad here and you rotate it, you still get both. It's just that the detail will usually take over the whole screen, and you can slide from the right. You kind of swipe in from the left, and you'll see that the master slides in on top of the detail. Okay? Makes sense? So that's split view, how it's arranged. Navigation controller. So navigation controller is like a stack of cards, okay, where each card is a different MVC. So here I have an all settings MVC, okay, inside of a navigation controller. Now, this navigation controller is responsible for drawing this title bar at the top, okay, this whole area in the top where it says settings, but it's not responsible for the actual contents of what's in there. That word settings is determined, just like in tab bar situation, by this MVC, okay? This MVC down here has a property on it. It's a view controller called navigation item. And navigation item has properties in it like the title, any buttons that go here, maybe a back button title, those kind of things. all would be in this navigation item of this all settings MVC, not of the navigation controller. All right? So here if I touched on general and I wanted the general settings, then of course the general settings would slide in, okay, and replace the whole contents here with a general settings MVP, yet another new MVC. And notice the back button by default will be set to have the name of the previous MVC. That other MVC is still in the navigation controller, it's just underneath. Okay, so this is a stack of cards, I just put another MVC on top, so the other one's still there. Okay, and you can also put toolbar items at the bottom here. Okay, that's also controlled by whatever MVC is showing. So this toolbar items is a property on UIView It's an array of UI toolbar item, and it'll let you put toolbar items down here. Okay, little small buttons. Okay, so again, if I click, let's say, oh sorry, yeah, the back button got the title there, but you can also set the title to something different if you want. Okay. So let's say I clicked on accessibility right here. I'd get another new MVC. Now I have 3 MVCs on my stack. Okay. Let's go ahead and click on another one here, a larger text right there. Now I get another one. So now I have 4 MVCs on my stack. Okay. Now I'm going to go and click on accessibility up in the top there, the back button. Now what happens? Now this MVC gets thrown away in the trash, out of the heap, gone forever. Okay? Now there's only 3 MVCs left. Okay? The other one is completely gone. It's important to understand that on an MVC, when you go back, the one that got thrown off literally gets thrown away. Okay? And so if we go back again, now that one got thrown away. Now there's only 2 MVCs in the world, okay, on top of each other. And of course, if we go back to the beginning, now we get back to here. This MVC we'll call the root view controller of the navigation controller. It's the one that's at the bottom of the deck. Okay, it's always in there. Okay, so let's talk about how that navigation controller works from our MVC standpoint. Okay, let's say I have an MVC here, and I just have too much functionality. I just can't fit all the functionality in my view. I need to put this somewhere else. So I create another MVC, okay, because somebody has to control this extra functionality. So there's another controller, okay, a whole other MVC here. Okay, and I want these two, they're related, okay, so somehow in this UI I get to this UI because this UI kind of all goes together in some way. It's related in some mechanism. Maybe it's master detail kind of effect or something like that. So how am I going to make this work? Okay, so I'm using UI navigation controller, and here's the UI navigation controller. Its view looks like this. Okay, it's blank. Okay, it's got room up here though for a title, back button, maybe some other buttons over here. But it never lives like this because it is an outlet called root view controller, okay, which is hooked up to some MVC. And when it's hooked up, the contents of the view of the navigation controller are the contents of this MVC's view. Right? Make sense? Kind of obvious? Now, there's probably some button in here that if I touch it, means I want to show this UI over here. I want this MVC. So if I touch it, what the navigation controller does is it moves over here, shows this view. This one's still around. Okay, it's just not showing, but it's still in the UI navigation controller stack. Okay, it shows this guy right here. Notice we get this automatic back button right there. If we press that back button, okay, then it's going to go back here, and look what happened to this MVC. Gone. Okay, completely got eliminated. If I press this button again to go back, it would create a new one. Okay, a brand new instance of this MVC. Okay, make sense? So that's how the navigation controller is working from an MVC standpoint. All right, now in these MVCs, how do I get at the other MVCs that I'm sharing the navigation controller or the split view controller or the tab bar controller with? How do I get to them, send them messages, talk to them in some way? And the answer is through this very important var in UIView okay? In UI tab bar controller, UI split view controller, and UI navigation controller. They all have this var. And it's an array of view controllers. It's all the view controllers in this thing. All the tabs in the tab bar, both this master and the detail and the split view, all the things on the navigation stack in a navigation controller. It can be an optional, like the tab bar case, it can be an optional. I don't think it's an optional for the other two. You have to look at the documentation there for that. But in a tab bar, this is just the array. I believe it's from left to right. Okay, so it's all the MVCs from the left tab to the right. And if you have more, then it spills into the order in the more tab. For a split view, 0 in this array is the master, and 1 is the detail. And for a navigation controller, 0 is the bottom card, and 1, 2, 3, 4, 5, 6, 7 is going up the stack. Okay, so the one that's visible would be the last one in this array. Okay. Got it? Notice this is settable. It's get and set, but we usually don't set our view controllers this way. Okay? Like split view, we usually wire it up in our storyboard. In navigation controller, we're usually navigating to those other MVCs. And tab bar, we also set up in our storyboard. Okay? So it is settable, but usually we're getting them. So that's great, but if I'm inside a split view controller, how do I get the split view controller I'm in so that I can access this property? And the answer is UIView has these 3 very important properties. Tab bar controller, split view controller, navigation controller, they're all optionals. They will tell you the split view controller you are in if you're in one. If you're not, it'll be nil. Okay? It'll also tell you, this one, what navigation controller you're in if you're in one. And you could be in both a split view controller and a navigation controller. Imagine a split view controller where the master is actually a navigation controller that you can navigate through. Okay, so you could have a navigation controller inside a split view controller, and any MVC that's in that navigation controller, this would be non-nil, and this would also be non-nil. Okay, because it would be both in both of those things. And once you get the split view controller or navigation controller in, you can find the other MVCs using this thing up here. So for example, if I have an MVC and it's the master in a split view controller, and I want to get the detail, I can just say split view controller, question mark, because it might be nil. And this is the chaining, remember? Everyone hopefully remembers chaining. I'm going to get the view controller, sub 1. Remember, number 1 is the detail. And that's going to give me the detail of the split view controller I'm in, if I'm in one. Otherwise, it would be nil. This would be nil. So this actually says detail VC UI view controller, but this would be detail VC UI view controller question mark. Okay? This would be optional. That's a bug in the slides there. Okay. So how do we wire up these MVCs? How do we get this all set up? Let's take a look at split view and briefly navigation controller. And then in our next lecture, we'll talk about how we transition between these various MVCs. Okay? Especially in navigation controller, how do we put more things on the stack? How do we make it go to the next thing? So for split view controller, you basically drag a split view controller out of your little utilities object palette in Interface Builder, just drag it out. Now, when you drag out a split view controller, you're going to get a whole bunch of other MVCs. It tries to help you out by giving you navigation controllers with table views in it, all that stuff. Just delete all that stuff. Okay, you just want the split view controller. It's being a little too helpful for you most of the time there. Okay, so you're going to drag that out, and then you're just going to control drag from the split view controller to the master and the detail. Okay, it looks like this. Here's my split view controller. I dragged it out of the utilities pane. I'm just control dragging to my calculator, for example, to be my master. When I do, this popover will appear, and the only 2 things that make sense to pick are master and detail. Okay, these are the only 2 choices that make any sense. Those don't make sense here. So let's pick the master. It's going to create a connection, the master connection. Control drag down here. I'm going to pick detail. It's going to make a connection down there. Voila, I've wired up my split view controller. Okay? All right. But split view can only do what it does on iPad, right? There's really, on most iPhones, everything except for the iPhone 6 Plus, there's really not enough room to have a split view. So we want to simultaneously put the MVCs that are our master and detail of split view into navigation controllers. And then iOS is smart enough, if it's on iPhone only, okay, iPhone 6 or iPhone 5 or something like that, it knows not to use the split view controller. It'll only use the navigation controllers. Okay, so let's take a look and see what that looks like. So here I've got that thing I just showed you, right? The calculator, the graph. Here's a split view controller. I'm just going to take this guy and put it inside a navigation controller. And the way we do that, easiest way, is to select it and then say embed in navigation controller. Same way we did embed in stack view, but here, since we're choosing a whole controller, we can't embed it in a stack view. So we're going to say embed in navigation controller, and it's going to embed this thing into a navigation controller, which is going to look like this. So split view controller, this is still the master. Now this navigation controller, this MVC, is the master, and its root view controller is the calculator. Okay? And the cool thing about this, like I say, if you run this on iPhone, it'll ignore this and just have your calculator in a navigation controller. And when you try to show a graph, it'll put this as a stack, a card stack, on this navigation controller. Isn't that cool? Okay? So that way it works on both platforms, exactly the same storyboard. All right? Okay. Yes, I'm just noticing, I'm mentioning here, you can put this one inside your navigation controller too. You don't really need to, okay? Only the thing that is the root view controller really needs to be inside of it. But if you put it, then you'll get a nice title along the top. You see you got a title there, calculator? You'll get that nice title here, even in the split view case. The only thing to watch out for is this detail will now be a navigation controller, not a calculator graph controller. You always have to be careful of that case. All right, so that's it for today. On Wednesday, we'll talk about what are called segues. That's how we transfer from one MVC to another, either in the split view or the navigation controller case. We'll do a demo, which is going to extend FaceIt. Okay, it's going to be called emotions. As you can imagine, we're going to show some emotions on our faces. Then I'm going to start talking about the view controller lifecycle. That's part of the two methods that I always delete when I start a new thing. We'll learn what those things are so you don't have to delete them. Friday, really good optional section, which is source code management. Remember, I've been not clicking that button. Now you'll know what that is, and you can click that button from now on if you want after Friday. And then next week, we'll talk about protocols, delegation, scroll view, all kinds of wonderful stuff. Okay? That's it. I'll be here if you have any questions.
For more, please visit us at stanford.edu.